Today we are going to find electric field and electric potential. Electric field and electric potential due to charged disk. Okay, I think this is our last distribution of charge to find electric field and potential. Okay, this is actually very similar to electric field due to a charged ring. Okay, suppose this is a disk. Okay, uh, this is a disk. Okay, uh, just a second, I need to, let's say this is a charge disk. Okay, what we will do, we will pick an elemental area. Okay, and we'll consider that as charged ring. Okay, and we know the electric field due to charging, so by the help of that we'll find electric field due to whole charge disk. Okay, I'm making it as, suppose at a distance of y. Okay, suppose this is a center of, okay, center of the disk. Okay, we are taking this ring. Okay, this is what it is, actually elemental ring. Okay, and the thickness of this ring is actually dy. Okay, this thickness, this what it is, dy. I hope you are imagining this. Okay, and we need to find electric field at this point, at the axis of charged disk. Okay, in the question, or it is given that sigma is what, its surface charge density of what, of disk. Okay, and its radius is what, r, right? So and this dy is at distance of y. Okay, from the center of a disk. Okay, now and charge on this partial not partial, elemental ring. Okay, this is what, elemental ring. Okay, charge on this elemental ring will be what, it will be sigma into dA. Okay, dA is what, area of that elemental ring. Okay, area will be what, it will be this length will be what, this circumference, it will be 2 into pi into y, and what is the thickness, thickness is dy, so area will be 2 pi y dy. Okay, so sigma into 2 pi y dy. We have got charge on the elemental ring. Okay, now we know that electric field due to due to a charge cube, okay, on the axis of a ring, it is what, it is, in the previous video I have told you, k into that charge is what, that is actually dq. Okay, into distance from center, that is what, x upon y square, plus, actually for this partial ring, y is what, your radius of a new partial ring. Okay, I am redrawing it. Let's say this is a ring. Okay, of radius y. Okay, and we need to find electric field at this point. Okay, and this point is actually x. So what will be electric field? Electric field will be k into, and charge on this ring is what, it is dq. So k into dq into x upon y square plus x square power 3 by 2. Have you got this? If you didn't got this, rewind the video. Okay, k into dq into x upon y square plus x square की power 3 by 2. Okay, now we need to put the value of dq from this equation. Let's say this is a equation 1. So dE will be k sigma 2 pi y into x dy upon y square plus x square की power 3 by 2. Okay, now what will be the net electric field? Net electric field will be dE, you need to integrate, and if you let's say I'm doing this in the previous step as well. Okay, just a second. Now if you integrate this, what will be the limit of y? y is actually varying from this point. This point is what? It is at the on the same axis where we need to find electric field. So y is varying from 0 to r. Okay, we are taking at a distance of y. Okay, that is from the center. So y is varying from what? From center to the circumference of a disk. Okay, so the limit will be from 0 to r. Now this is all sorted. You just need to integrate this equation. Okay, so electric field will be, just a second, electric field E will be what? You need to take common terms out. So it will be k sigma 2 pi x. Yeah, these terms will come out, and here it will be y dy upon y square plus x square 3 by 2. Okay, you can do at your home this integration. I'm just directly writing the result. Okay, because you need to take by substitution you can solve this that this equation, this integration. Okay, y square you can take something, then integrate, differentiate it and put in the place of y dy, somewhat like that. Okay, the final expression will be sigma upon 2 epsilon naught 1 minus x upon x square plus r square. This will be under root. This will be the final expression of electric field due to a charged disk, okay, at its axis, right? So I have a question for you, that what will be the electric field at the center of a charge disk? Okay, and this x is what? This distance. Okay, what will be the electric field at the center of a charged disk? Okay, you can do it. Okay, I'll give you the hint that for center this x will become what? 0. Okay, now our second thing. Okay, we need to find electric potential. Okay, where? At the axis of a disk. Okay, electric potential. Okay, this is also a very common approach. We'll do it with the help of the previous one. Okay, here I have made this. Suppose this is what? This is your disk. Okay, again we'll take what? We'll take a elemental ring. Okay, with of thickness of dy. Okay, just a second, I need to make. Okay, of thickness dy. Okay, this radius is what? Capital R, and this is at a distance y, and we need to find electric potential at this point at a distance x. Okay, let's say this point is P. Okay, and sigma is given. Okay, that is surface charge density. Okay, uh, we'll take a elemental charge dq. Okay, uh, on this ring. Okay, let's say this charge is what? Dq, and we'll find electric potential due to this charge. Okay, so electric potential due to this charge at this point P will be what? Let's say it is dV. dV, it will be what? K dq upon that distance is what? It is actually under root of y square plus x square. Y square plus x square. Okay, this is a elemental potential. Okay, now dq, you know. Okay, dq will be what? Dq, I'm writing it here. dq will be, you write in your copy, I'm also writing, it will be 2 pi y, that is circumference, into dy into sigma. Okay, this is what? This is dA, this is sigma into d, that will be dq. Okay, you need to put this dq in this equation. So it will be V is equals to K 2 pi y into sigma into dy upon root of y square plus x square, and y is varying from 0 to r, right? Again, if you take terms that are common uh, outside the integration, this will be y dy upon root of y square plus x square, okay, and 2 pi k sigma. I think these term, these term will come out of the integration because they are constant, okay. 2 pi k into sigma, and you need to solve this integration, okay. I hope you have solved for the electric field. In this part I am telling you how to solve this integration, okay. Because there will also be putting of limit as well, okay. Suppose x square plus y square is equals to z, okay. Then when will be 0, okay, when y is 0, your z is what? It is x square, and when y is what? R, then z is x square plus r square, okay. So v is pi k sigma, okay. It will be dz upon root of z, okay. So after that 2 pi k sigma, this will be root of z, and now we will change limit, okay. This is 0 to r, okay, from x square to x square plus r square, okay. Now after solving this, what you will get? You will get uh, this is actually 2, okay. uh, just a second, this is actually not 2, yes, okay. You will get sigma upon 2 epsilon naught. I am converting in terms of 1 by 4 pi epsilon naught, changing k to 1 upon 4 pi epsilon naught under root of r square plus x square minus x. This is what? Electric potential at the axis of a charged disk, okay. So we have covered electric field and electric potential due to charge disk, okay, on the axis, okay, right. Okay, thank you.